Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at previous year questions of physics asked in medical and engineering entry exams in India. So today we're dealing with a particularly important chapter. This chapter deals with electrostatics, and the name of this chapter is Electrostatic Potential and Capacitance. This is the second chapter in the grade 12 syllabus for physics in CBSE. So we're looking at some very important questions in this episode. Here lies the first. Find the charge on the 2 microfarad capacitor here. So in this schematic, you can see that you have 2 batteries of 10 volts each and 3 capacitors, one with 1 microfarad, the other with 5 microfarad, and the last one with 2 microfarads. So we need to find out the charge passing through 2 microfarads. Now notice that in this schematic, all these 3 capacitors join together at a point A. Let's take that as B. So at point B, all of these capacitors are being joined together at a single point. And if you take the other side of the 2 microfarad capacitor, you will get point A. Now, let's suppose point A has a potential of 0 and point B has a potential, say, V. We're now going to use the conservation of charge in this question. So how do you conserve charge? Well, the basic formula that we're going to apply is Q1V1 plus Q2V2 plus Q3V3 equals 0. So that means Q1, that is since conservation of charge is the unit that we're taking, so it's Q1 plus Q2 plus Q3 equals 0. So that means C1V1 plus C2V2 plus C3V3 gives you 0. So now that we got the correct formula, let's apply the values. C1 is, let's say, 1 microfarad. So 1 times V is the potential at point B, and then it is passing through a 10-volt battery. So it's from positive to negative, so the 10 volts are getting decreased, so minus 10. So that is 1 times V minus 10 plus 2 times you have V on point B and A at 0, so V minus 0. And then you will have the third capacitor, 5. Now that is and then the change in voltage will be, the change in potential will be from B, that is V, to passing through the battery, so that is minus 10. So 1 times V minus 10 plus 2 times V minus 0 plus 5 times V minus 10 is equal to 0, according to the law of conservation of charge. So V minus 10, V minus calculated as Q equals C times V. So the charge in this case is the quantity that we need to find out, and then the capacitance here is 2 microfarad, and then the voltage is 7.5 volts. So 2 times 7.5, so that's 2 times 15 by 2, so that is equal to 15 microcoulombs. So the option that is correct will have the correct answer as 15 microcoulombs. That is the total charge. So if you were to look at our options, you can see that option C is the correct answer for this question asked in 2018. The important thing is to find out the endpoints of the wire that contains the 2 microfarad capacitor. Take one of the voltages as V and the other voltage as 0, and then we apply the law of conservation of charge. So that is Q1 plus Q2 plus Q3 equals 0. And then you will take Q as CV and then find the voltage. After finding the voltage, just multiply the capacitance that is in question times the total voltage to get the total charge on the given capacitor, which in this case is 2 microfarad. So option C, 15 microcoulombs, is the correct answer. Next question. Electric field inside the given capacitor with a dielectric is E, and the dielectric constant of the material is K. So you need to find the charge density on the plate. So S basically stands for sigma. So sigma is the, representation of charge density. So we need to find out the charge density when we have the values of E and K given. So we know that E equals 6 into 10 raised to 5 volts per meter and K equals 6. So we need to find out the value of the sigma, that is charge density on the plate. So how do we solve this? So we will find out the electric field on a given surface. So electric field E is equal to sigma divided by epsilon naught times K. So we can apply the values that we have. So E, that is the electric field, is 6 into 10 raised to 5. The value of sigma is the value that we need to find out. The value of epsilon naught is, epsilon naught is basically permittivity of free space. So therefore you can write that as a constant value. So the constant value for permittivity of free space is 8.85 into 10 raised to minus 12. So sigma divided by 8.85 into 10 raised to minus 12 times the dielectric constant, which in this case is 6. So now we'll just find the value for sigma. So sigma is equal to 6 times 6 times 8.85 into 10 raised to minus 12, and then since the voltage is raised to the power of 5, so you'll multiply 10 raised to 5 as well. So basically you get 36 times 885 divided by 100 times 10 raised to minus 12 plus 5, so that gives you minus 7. So you already have minus 2 here, so you get 36 times 885 into 10 raised to minus of 9. So minus 7 minus 2 gives you minus 9. So all you need to do is to multiply 885 by 36. 5 6 are 30, 8 6 are 48, plus 2 is 50. I mean it's 3, so that's 51. Then 8 6 are 48. 48 plus 5 is 53. 5310. Moving on, 5 3s are 15. 8 3s are 24. Plus 1 gives you 25. 8 3s are 24. Plus 2 gives you 26. So now on adding this, so this is 1, not 0. So 0 plus 0 is 0. 5 plus 1 gives you 6. 3 plus 5 gives you 8. 5 plus 6 gives you 11. 1 goes to the next place. So 2 plus 1 gives you 3. So basically you have 31860 into 10 raised to minus 9, which when you use significant figures and use the scientific notation, you will get 3.18 in 186 into 10 raised to minus of 5. So the value of sigma is 3.186 into 10 raised to minus 5. So this is the correct option. And if you look at our given options, you can see that option C is the correct option. Note that option D has the wrong order, so therefore it is incorrect. and in the other options that are A and B, both the value and the order are different, so therefore those options are incorrect as well. So the right answer is option C, 3.18 into 10 raised to minus 5. So over here you need to find out the you need to use the electric field formula, which is sigma divided by epsilon naught times K if you have a dielectric constant. So that's all for this question. Let's look at the next question. A parallel plate capacitor with air as a dielectric has a capacitance C. A slab of dielectric constant K having the same thickness as the separation between the plates is introduced so as to fill 1/4 of the capacitor, as shown in this figure. So you need to find out the value of the new capacitance. So how do we solve this question? So as you can notice, you have two plates which are parallel to each other, and you can see that 1/4 of this medium, 1/4 of the plates, of the distance between, of the space between the plates, is occupied by a dielectric of a constant K, and the rest is occupied by air. So the condensers with K and air are in parallel. So we have parallel plates, so we use the formula for a parallel plate capacitor. So the formula for capacitance of a parallel plate capacitor is C equals K E naught A divided by D. If you have a dielectric, if there is no dielectric, just multiply as 1, so you get E naught A divided by D for air. So for air, the capacitance is given as C, so therefore C equals E naught A divided by D. So now we need to find out the capacitance of the combination. So we take that as C dash, and we take the capacitance through air as the dielectric medium as C1, and through K as C2. So let's find the values of C1 and C2. So over here, C1, since it does not have the dielectric constant, it will be E naught divided by D. And now notice that the area covered is 3/4. So therefore you will write 3A divided by 4. So the total formula is 3 epsilon naught A divided by 4D. So this is the value of C1. Similarly, for C2, we take epsilon naught times K, because we have a dielectric constant, divided by D, that's the thickness or the distance between the plates. And since over here the plates occupy 1/4, since the dielectric occupies 1/4 of the space, 1/4 of the area of the plates, you will write A by 4 inside the bracket for area. So you will get K epsilon naught A divided by 4D. So now we just need to add these two to get C dash. So C dash is equal to C1 plus C2. So that is equal to 3 epsilon naught A divided by 4D plus K epsilon naught A divided by 4D. So therefore you can take epsilon naught A divided by D, and then you can take 1 by 4 as well. So these are the things that you can take common out, and inside you will get 3 plus K. So the reason why I separated whatever is taken out into two separate brackets is that we know C is equal to epsilon naught A by D. So we can just replace that by C. So C dash is equal to C by 4 times 3 plus K. So therefore the correct value for the new capacitance is C by 4 times 3 plus K. So if you were to look at our options, you can see that option A is the correct answer to this question, which by the way was asked in 2017. Let's look at this question. A large solid sphere with uniformly distributed positive charge has a smooth, narrow tunnel through its center. A small particle with negative charge, initially at rest far from the sphere, approaches it along the line of the tunnel, reaches its surface with a speed v, and passes through the tunnel. You need to find out the speed at the center of the sphere. So, how do we start solving this question? So we have three separate cases of the position of the particle, and from there we can calculate its potential. So in the question it says that a small particle with negative charge is initially at rest far from the sphere. So that means we can take this as infinity. So therefore the potential at infinity is equal to 0. So that is one value gained. Next, it approaches this particle approaches the sphere along the line of the tunnel and reaches its surface with a speed v. So we need to find out the potential at the surface. So potential at the surface of the sphere is kq divided by capital R, which in this case is the radius. So what next? We need this particle eventually reaches the center. So we need to find out the potential at the center as well. So the potential at the center is defined as 3/2 times the potential at the surface. So therefore that is 3/2 times kq by r. So we know the three values of the potential. Let's consider m as the mass, minus q as the charge, and v0 as the speed at the center of the sphere. So this is the quantity that we need to find out. So how do we solve this question further? We use the formula for kinetic energy and we equate it to q times the potential. So that means half mv squared equals q times v. This is the correct formula. So on applying it, so the first case scenario is from infinity to the surface. So what is the kinetic energy that is lost? So 1/2 times m times the final velocity here is v, so that's squared because the initial velocity is 0. So we don't take that. Then we have q times the potential. This is the potential at infinity minus potential of the surface. So that equals q times kq divided by r. Now if you're wondering how is that, because potential is taken as negative when it goes outside the part is outside the sphere, so potential energy is taken negative. So negative times negative gives you positive. So q times kq by r. Next, the second case is from infinity to the center of the sphere. So what happens here? So 1/2 times mv0 squared gives you q times v infinity minus v center. So that is q times 3/2 kq by r. So let's take the above equation as equation 1 and this as equation 2. So what we're going to do is we're going to divide equation 2 by equation 1. So if you take equation 2, that is half mv0 squared, and then the denominator is half mv squared, and that is equal to q times 3/2 kq by r whole divided by q times kq by r. So as you can see here, half gets cancelled, mass gets cancelled, the velocities don't get cancelled. The charge gets cancelled, the constant gets cancelled, and the radius and the distance as well, that gets cancelled. So therefore the ratio is 3 by 2. So v naught squared divided by v squared is equal to 3 by 2. So therefore v naught squared is equal to v squared times 3 by 2, which can be calculated as 1.5. So therefore the value of v naught, that is the speed of the particle at the center, is under root of 1.5 times v. So in a normal scenario you will have to calculate it, but over here we just need to find the relation, that's it. So this is the correct answer. The speed of the particle at the center is equal to under root of 1.5 times the velocity at the surface. So therefore in the given question you can see that option D, root of 1.5 times v, is the correct answer for this question, which was asked in 2017. Now we've come to the final question of this episode. A hexagon of side 8 centimeters has a charge 4 microcoulombs at each of its vertices. Diagram shown here. The potential at the center of the hexagon is. So how do we solve this question? Well, the figure given is a hexagon, so therefore we can start with that. So let's consider O to be the center of the hexagon. And as you can see, what we have is a regular hexagon with side 8 centimeters. So 8, 8, 8, 8, 8, 8. So all of the sides measured up to 8 centimeters. So therefore this hexagon, A, B, C, D, E, F, is regular. Now what happens if you have a regular hexagon? Well, you have 6 sides and the total angle subtended is 360. So 360 divided by 60 gives you, well, 6 sides. So if you were to do 360 divided by 6 sides, that gives you 60 degrees. So the triangle that is subtended for each diagonal to the center, that is 60 degrees. And you know which triangle has 60 degrees? An equilateral triangle. So therefore that means triangle OAB, triangle OBC, triangle OCD, triangle ODE, triangle OEF, triangle OFA. So these are equilateral triangles, and they are equilateral triangles in a hexagon that is regular. So therefore that means, since if it's an equilateral triangle, the sides of the triangle are equal. So using that, all of the diagonals that are OA, OB, OC, OD, OE, as well as OF are equal to 8 centimeters, which we can write as 8 into 10 raised to minus 2 meters. So now what we need to find out? We need to find out the potential at the center O. So potential at a point O. So potential at a point is given as KQ by R. But since we have 6 vertices here, so the total potential here is 6 times V. So that is 6 times KQ by R, which is 6 times 9 into 10 raised to 9 times the charge, which in this case is 4 microcoulombs. So that is 4 into 10 raised to minus 6 divided by, next you will have the radius So which in this case is the distance. So the distance given is 8 centimeters because all the sides are equal to 8 centimeters. So therefore, r is equal to 8 into 10 raised to minus 2. So 4 goes into 8 2 times, 2 goes into 6 3 times, 3 times 9 gives you 27, and then you will have 10 raised to 9 into 10 raised to minus 6 gives you 10 raised to 9 minus 6, that is 10 cubed. So therefore you will have 10 cubed divided by 10 raised to minus 2, so that is 10 raised to 3 minus 2, so that is 10 raised to 3 plus 2, which is 10 raised to 5. So therefore the total potential is equal to 2.7 into 10 raised to 6 volts. So that is the total potential for this hexagon. So this hexagon has a charge 4 microcoulomb at each of its vertices. The potential at the center of the hexagon is option A, 2.7 into 10 raised to 6 volts. And that concludes this question, which was asked in 2015, as well as our episode today. We hope you found this episode interesting. For getting more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We've also uploaded a mind map based on the chapter Electrostatic Potential and Capacitance. You can check that out from the link of the playlist given in the description box down below. For watching more of our videos from NEET JEE-Main, you can also hit the link in the description box down below for the playlist. So until the next webisode, take care, stay safe, bye-bye for now.